This conference will now be recorded.
So yesterday's session, we were trying to understand what is EKS and how different it is from self-managed Kubernetes cluster. Today we'll try to set up the Kubernetes cluster, EKS Kubernetes cluster using AWS console. So first, let me log into the console. We'll get started. One second, please. Give me a second. Okay. So first, we'll try to create a Kubernetes cluster. You following these steps. As a first step, we will be creating a IAM role to create a EKS cluster. So when we are creating a EKS cluster, we need to create, we need to attach one role, okay, to set up the Kubernetes cluster. First, we will create one IAM role. This IAM role we will be using while creating a EKS cluster. So log into the AWS and go to IAM. And go to the roles. Go to the roles. And here, create one role, right? This EKS cluster role. So let me create a role. I'm creating a role with some name, okay? But select the use case as EKS. You have a use case here, right? So you have a use case. You select the use case as EKS. EKS. When you try to create the role, you select the use case as EKS. Then select this one, EKS cluster. This, okay, allows access to the other AWS resources that are required to operate clusters managed by EKS. So basically, we are going to use this role with EKS cluster. So we are giving some AWS permissions, some other services to, service permissions to the EKS cluster. So we need a role. So we select EKS, then select this one, EKS cluster role, right? Basically, we are creating a role with this policy, EKS cluster policy. Give some name and create a role. EKS cluster role something, some name, something like this, some name I am giving. I am creating a role with this policy. This role we will be using while creating a EKS cluster. So that EKS cluster can manage, can access other AWS services based on the policy. Now the next step, what we will be doing is, we will be creating a separate VPC. We will be creating a dedicated VPC. In that VPC, we are going to create the cluster. We are going to create the nodes. What is VPC? You guys already know, right? What is VPC in AWS? Basically, a network. a private network. VPC is a network where we can create the servers, right? We can use default VPC also. I mean to say you can create a EKS cluster in the default VPC. But instead of using the default VPC, we will be creating a separate VPC, separate network, where we will be creating the EKS cluster and its nodes, its worker nodes. So VPCs, how many ways we can create? Basically AWS, how many ways we can manage, right? We can use console, or you can use Terraform, or you can use cloud formation template. So I am using the cloud formation template to create the VPC, infrastructure as a code. So the cloud formation template I am taking from the official AWS, right? AWS itself has given the cloud formation template, right? So the cloud formation template is in the form of YML. So this is the URL, cloud formation template URL. So using cloud formation template, we will be creating a VPC. So how to create this VPC using cloud formation, right? So let me go to the cloud formation. It is again infrastructure as a code. Create and manage resources with the templates, cloud formation template. So let me go to the cloud formation. I think I already have one VPC, but yeah, that is fine. I'll create another VPC. So I already had this one. So let me go to the cloud formation. So I'll create a VPC using cloud formation template, VPC and its components. So go to the cloud formation template and click on create stack. So I already have a template. My template is the cloud formation template is part of this AWS S3, this URL. This URL I am just taking, providing here. So this cloud formation template has how many subnets to be created, how many subnets to be created, route tables information, whatever needs to be created. So I am taking this one. Okay. That URL I have provided here. Click on next. Give some name, whatever name, something like this. So whatever cloud formation template I have given, right, that YML file, there they have all the details. What is the VPC CIDR and how many subnets it is going to create, all the details. So as per my cloud formation template, it is creating 2 public subnets, 2 private subnets with this CIDR. So I'm giving just name EKS VPC, something like this, whatever name you want to give. Now IAM role here, you just leave it, don't give anything. Just click next, create a stack. Now the cloud formation templates, infrastructure as a code. Now it will create a VPC for us and subnets in that VPC, route tables, right? When I go for a VPC here, when I go and check VPC here, now I can see that VPC is getting created. You see this one, right? It is getting created. Now its related subnets also. Its related subnets also getting created. Okay, and route tables, all those things. Now We just created a VPC using CloudFormation template. That's it. Instead of manually creating the VPC, we use the CloudFormation templates to create the VPC. So in that VPC, right, this one, it is in progress. It is getting executed. It is going to create some resources. Now you see here, it has created IGW, it has created a NAT gateways, it has created a private subnets, public subnets, right? Everything is getting created by that CloudFormation template. Now, this is creating VPC now. The next step, we can create a EKS cluster. We can create a EKS cluster now. So now I have a VPC to create a cluster. So next step, I will go and create a EKS cluster. Again, search here EKS, right? EKS, Elastic Kubernetes Service. Most trusted way to run the Kubernetes applications. So now here, Amazon EKS clusters. I don't have any clusters as of now. So let me click on create cluster. I'll create the cluster. Now here I can give some name, whatever name, something like this, EKS cluster. And what version of Kubernetes you want to use to set up this cluster. So it is supporting 1.20, 1.21. 1.20 is the default one. So I am also selecting this one, 1.20. If you want to set up Kubernetes with 1.21, you can use this one. But let me take 20. Now here the role, select the IAM role to allow Kubernetes control plane to manage AWS resources on behalf of you. So here I will select that role. We created one role, right? EKS, the first step. In the first step, we created one role. That role I am selecting here. I am attaching that role to the EKS service. So that EKS control plane components can manage the AWS resources based on the policies. So this is the role I created. I am going to select this one. EKS cluster role. Then tags. You can give a tags, whatever, key value pair, something like this. Then next, in which VPC you want to create this cluster. I don't want to create this one in a default VPC. I'm going to select this one, whatever VPC we created using CloudFormation, at this one, the last one. So in that VPC, I'm creating a cluster. That VPC has these many subnets, right? All the subnets has been selected. And security group. Here you select this security group. This one, the security group, whatever got created, cluster communication with worker nodes. And also you select this one, both. Okay, you select the security groups, whatever has been created. This is created by your CloudFormation. Select these two. Now, cluster endpoint access. When we are creating a Kubernetes cluster, the cluster endpoint access. You can create a private endpoint, or you can create a public endpoint, or you can select a public and private. If it is a private endpoint, what does it mean? What does it mean basically? Cluster endpoint. If it is a private endpoint, we will be able to access the API server. We will be able to access that Kubernetes cluster Can we access from different networks, different internet? Can you talk to the Kubernetes cluster from internet to deploy the applications or to delete the applications, right? If it is a private, you have to access this only within the network, within internal. But if I select public, will I able to access my Kubernetes cluster from different networks? I mean to say, can we deploy the applications directly from internet if you have a kubeconfig file, if you have a access? Yes. So in real time, it will be private subnet, private endpoints only, private access only. But for now, I will be selecting this one, public and private, which means the cluster is accessible outside of your VPC also, and worker node traffic to the endpoint will stay within VPC. So I will be selecting private and public for now, the endpoint access. Now, when we created a Kubernetes cluster, if you remember, did we deploy some network add-on, network plugin while setting up the Kubernetes cluster? When we set up the Kubernetes cluster, the CNI implementation, container networking interface implementation, in the self-managed, did we apply some network plugin, right? VNet. Similarly, we are trying to select this network plugin, CNI, container networking information, container networking interface, enable pod networking within your cluster. So what, CNI, it is supporting where basically AWS has their own CNI for Kubernetes networking. So that is a Amazon VPC CNI. It is one plugin. The way we have a VNet, right? This is one plugin. Amazon supports native networking with Amazon VPC container networking interface, CNI, their own CNI. So this is the CNI which will be used. And also kube proxy version, core DNS version. I'm going everything with the default. Now we can enable the logging using CloudWatch. You can enable the logs, API server logs, right? You can enable the audit logs, authentication logs, control manager logs, scheduler logs, everything. If you enable this one, the logs will be, we can monitor this API server, this control manager using CloudWatch logs, but which I am not enabling as of now. With this information, I am creating a cluster, EKS cluster. This is just a control plane. I will be getting a control plane. Now I am creating a control plane. But can I see the servers? I mean to say, do we have access to the control plane servers as we discussed? Who will manage this complete control plane? Who will manage this complete control plane? AWS. Now I'm just getting a control plane. I mean to say the masters. But did I add workers? I mean to say, did I create any worker groups as of now? We have not created any worker group. Now, what I will be doing? Next one, I'll create a worker group. I'll create a worker group. Now control plane is ready. Master nodes are ready. It is going to be created. We don't have a workers. If I try to deploy, will pods will be created since you don't have any worker groups? I mean to say workers. No. So what I will be doing now? I will be going to create a worker groups, worker nodes. Now let's see. If you see, now I have a cluster. The cluster is getting created. It is going to take some time. EKS, right? I have given this name. Now, if you see here, we have a compute section. When I go to the EKS, when I go to the clusters, I have this cluster. Here, if you see, there is a compute section. Do I have any nodes, node groups? Nodes. No node groups. This cluster doesn't have any node groups. Nodes that are part of Amazon EKS managed node group are not shown in the AWS console. Okay. Now here I have not created a node group, which means we don't have a nodes. Do I need to manually create the servers? Do I need to execute any kind of a QBDM join token if I want to set up EKS cluster, EKS nodes? Do I need to manually create a servers? Do I need to manually install the required softwares? No. So we are going to create a node group. We are going to create a node group. So still the EKS is still under creating process, right? Still it is in creating process. It will take some time. Once it is completely ready, here, right? I can create a node group. In the background, that node group is nothing but what? Here I am going to create a node group. But in the background, AWS, what will be created basically? It is going to create one auto scaling group. If I create a node group here, group is nothing but, so in that case, that worker nodes will be managed and created by whom? The EKS worker nodes will be managed and created by whom? Which service will look after your EKS? AWS only. AWS auto scaling group. AWS auto scaling group. Now let me show that. Still, it is going to take some time. It is going to take some time. The cluster is still creating. It will take some time. Let's wait. In the meantime, let me terminate whatever servers I have created. Those are self-managed Kubernetes clusters. We have some servers already created, right? Those are created ourselves. Those are created by ourselves. And we have set up a Kubernetes cluster using QBDM, right? I don't need that cluster anymore. Let me terminate that cluster. These servers, these are self-managed, right? If anything goes wrong with your master self-managed Kubernetes cluster with workers, will you get another master, another worker? If you created yourself and you configured yourself? No. Now I don't want this one. I am terminating all these servers. These are self-managed. I don't want this cluster anymore. I am trying to demonstrate EKS now. Now, let me see here. If this is ready, I'll create a node group. Still it is creating. It will take some time, approximately 5 to 10 minutes it will take. Still under creation. Once it is completely ready, then only we can add a node group. Go to the configuration section. Here, compute. Here, as of now, we don't have any node groups. This is not enabled because this is still under creating. It will take some time. Let's wait. It is taking some time. Just wait. Let it in progress. In the meantime, what I will do? So we need to create a worker group. But before creating a worker group, I mean to say node group, that node groups are worker groups. I am going to create one IAM role with these policies. I am going to create one IAM role with these policies. For which one? For what purpose we are creating IAM role with these policies? Basically, this IAM role we will attach to that node group. While creating a node group, we will use this IAM role. So basically, we are attaching this IAM policies, IAM role with these policies to the workers. What is this policies? Right? Amazon worker node policy, CNI policy, and container registry. Suppose you are trying to use EK this ECR repository, container registry. Now you are using your you are maintaining your images in the ECR private repository, and you are trying to deploy those images in your Kubernetes cluster. Does worker nodes, I mean to say, does your Kubernetes nodes requires access to the ECR to pull the images? If it image is in ECR, does your worker node requires permissions to pull the images from ECR? So in that case, that Kubernetes machine, that Kubernetes worker node is basically a EC2 instance, which will be managed by the one auto scaling group. So if I attach that IAM role to the auto scaling group, obviously that will be attached to the server. If that server, that worker node has these policies attached, will it able to pull the images from ECR, and will it able to use that CNI, container networking, that worker machine? So we need to create IAM, we need to create IAM role with these policies. So your Kubernetes worker machines will have policy so that your have a permission and other stuff. Okay. So for that one, first I'll create a IAM role, then I'll create a worker group. This IAM role is for a workers with these policies. Still, yeah, now this is ready. Now this cluster is active. Now I can create a node group. But before creating a node group, I need one IAM role to be created. So let me go to IAM. Let me go to the roles. Let me create a one role. So here, select the use case as EC2 this time. when you are creating a role for these workers, right? For worker nodes, select the use case as EC2, click on next, click on next. Here permissions, right? You try to attach these policies. Amazon EKS worker node policy, search with that one, select that, and again search with this one, select that, search with this one, and select that. Now I am creating one IAM role with these policies, these three, which this role I am going to use with my worker node, CKS worker nodes. So let me give something like this. Let me create IAM role with this policy. Now this one I will use while creating a node group. As of now, I don't have any nodes. We don't have any nodes. Now I will be creating a node group. You give some name, whatever name, EKS node group. And here, select that role. So select the IAM role that will be used by all the nodes in this group. So we created one role, right? That EKS, refresh here if it don't reflect. Now, if you remember, we created this role, right? EKS node role with those three policies. Now, let me select that IAM role. Now, in the background, I am creating a node group. In the background, it is going to create an auto scaling group, and it will use some launch configuration. It will use some launch configuration. You don't, if you want to use launch template, you can select this one, but you don't have any launch template. So you use the default one, launch configuration. AWS auto scaling, right? What do we have in the launch configuration? Where do we use the launch configuration? We already discussed in AWS. What is launch configuration? Launch configuration is input for your auto scaling group, right? Now I am creating a worker group, node group. So who will create the nodes? AWS will create the nodes. And in the background, it is auto scaling group. So do I need to install required softwares? Do I need to execute QBDM giant tokens? All those stuff? In this case, no. It is going to use some launch configuration that have instructions to install the Kubernetes softwares, and it will join the cluster. So don't select anything. Go with the default launch configuration, whatever it has. Now, let me add a labels, whatever I want to give. EKS node, something like this. Now, if you want to taint, you know what is taint, right? If you want to add any taints to the nodes, you can add the taints. But as of now, I don't want to add any taints to the nodes. So the tags, labels, these labels will be attached to your nodes. If you remember, if you remembered, we manually added labels to the nodes, right? Labels to the node by executing kubectl labels node, right? Similarly, here, while creating a node group itself, you can add whatever labels you want to add, Kubernetes labels. In the background, whatever I am selecting here, this will be added as labels for your node, right? If you want to add a labels, you can add here. Or if you don't want to add any labels to the nodes, you can leave this. Now, the tags. These tags is basically AWS tags. something like this, whatever you want to give. Now, let me go to the next. So now, what is the AMI type for that worker nodes? What is the AMI type for that worker nodes? Now, AMI type, it is supporting only Amazon Linux. So the worker nodes will be created using Amazon Linux, right? And what type of server? On demand or spot or whatever. I'm going with on demand. Now instance type. So now what should be the instance type for your worker nodes? With what capacity? If you see here, it doesn't support T2.micro. Here it don't support T2.micro. Now it supports T3.micro, T3.small like other. But I am going to deploy a lot of applications like Prometheus, Grafana. I want to demonstrate what is Prometheus, what is Grafana, and also I am going to deploy a lot of applications. If I select this T3.small or T3.micro, I may not able to demonstrate. So I am going with this one, T3.large. T3.large. So the worker nodes will, what is the capacity of the worker nodes? Whatever I am going to create now for this Kubernetes cluster, each worker node, what is the capacity? 2 core CPU and 8 GB RAM. And again, it is not free tier eligible, guys. It will be chargeable. It will be chargeable because T2.micro is only free tier. Others are not free tier eligible. So I'm selecting T3.large. It is chargeable. Now the disk size, what is the EBS volume for that node? So I'm going with the 20 GB. Now here, node group configuration, minimum size, maximum size, desired size. Now what is the meaning of minimum size? If I give 2, minimum how many nodes I will be having for this cluster? Minimum how many nodes? If I say 2, 2. And here if I say maximum as 5, up to how many I can scale? Kubernetes clusters can scale up to 5 nodes. Right? I'm saying minimum as 2, maximum as 5. Now, here, maximum unavailable, right? Set the maximum number or percentage of unavailable nodes during the node group version update. Suppose you are doing some upgrades, right? So AWS will do the upgrades in the background. When they are performing the upgrades, how many nodes can be maximum unavailable when they are performing? Suppose if I have 2 nodes, if I say maximum unavailable 2, when they are performing the upgrades, does any node is available to serve your applications? If I say maximum unavailable 2, when they are performing the upgrades, when they are doing the upgrades in the background, AWS. So if I say 2, there won't be any node available when they are performing the upgrade. So that's why I'm just giving 1. When they are performing the upgrade. So with this information, I'm creating a node group. So the node group will be created in the same VPC in subnets. And do you want to SSH to the nodes? Whatever nodes is created for this cluster, do you want to SSH? If you want to SSH, select this one. Yes, I want to SSH. What is the key to SSH? If you want to SSH, pair. What is the key pair you want to use? This key pair I want to use. Now allow SSH access from, whether you want to access from all the IPs, I mean to say everywhere, or specific security group. You want to select some security group, you can select that one. Otherwise, it will create one security group with anywhere. Port 22 will be open for anywhere. Right? If you want SSH from anywhere, but in real time, do you 0.0.0/0 for port 22? Not only for port 22, like most of the ports. Do you open the ports for everywhere in the real time? Only within some IPs, within some ranges, we will open, not for everywhere. But for now, I'm selecting all. With this, I'm creating a node group. Now, the moment I click on node group, creating a node group, in the background, I'm going to get one auto scaling group. I'm going to get one auto scaling group in the background. I'm going to get one scaling group in the background. If I go to this auto scaling group, now I can see that auto scaling group. One auto scaling group. Here I can see one auto scaling group. So this auto scaling group is for which one? Basically, this auto scaling group is basically for that EKS nodes, worker nodes. This auto scaling group got created. Now this auto scaling group is going to use some launch configuration. It is using some launch configuration. This launch configuration has all the data, the bootstrap script, which is going to install Kubernetes, and it is going to execute all the kubedium, whatever commands, right? It has some user data. It is going to use this auto scaling, this launch configuration, right? It has all the information. In the advanced details, I can see the user data. So they are going to execute some script. They are going to execute some script, the user data script, and they are joining the token. There, you see, there are some commands which will be executed. So this launch configuration is used in this auto scaling group. This auto scaling group is managing our worker nodes. Now, if you see, do I got two nodes now in my AWS? If I go to the EC2 section, now here I can see two more servers got created. Network is little slow. That is fine. If you see, can you see two machines with a T2.large? Sorry, T3.large. Do you see two machines got created with a T3.large capacity? One is getting initialized, another is completely initialized. So who is managing these nodes? Basically, these are EKS worker nodes. Who is managing these nodes in the background? In the background, it is managed by one auto scaling group. But if you see the control plane, we have a master's control plane, but do we have any control or visibility on the control plane or masters? Here, can I see that EKS control plane servers? That EKS control plane is completely owned by whom? That is completely owned by AWS. Now, I want to access this AWS. I want to access this AWS, and I want to deploy the applications. Now, how can I communicate with this cluster? I want to access that cluster to deploy the applications or delete the applications or update the application. How can I communicate with the cluster, Kubernetes cluster? Basically, how do we communicate using to the Kubernetes cluster? CLI. What is the CLI? kubectl, right? Now I'll create some machine to separate machine to access the Kubernetes cluster to deploy the application client machine. I'll create one instance. Using that instance, I will communicate to the cluster using kubectl commands. Now let me create one server just to access the cluster to deploy the application. So I'm creating one server again manually. This is basically Kubernetes client machine. This can be this can be a Jenkins server. This can be any other server. Using this server, I want to access the cluster. I want to access this cluster. This is my audio is breaking in between. Is it dropping in between? Okay. Let me switch the network. Just give me a second. I'll try to switch the network. Yes, am I audible now? This time, I hope I am audible now. Yeah, okay. Is my screen visible? Yeah. So now how to access that application, that cluster I want to deploy. So what I will be doing, I will be creating one server just to access the Kubernetes cluster to deploy the application. So since I have created a public endpoint, can I directly communicate from my laptop also? If I have a kubectl installed, if I get the kube config file for that cluster, Can I directly communicate from my laptop also? Can I execute kubectl commands from my laptop also? Yes, you can do that, because you have created a public private access. Now I will be creating one server in AWS itself. This can be your Jenkins server. Let's consider this can be any other server. Suppose let's consider this is your Jenkins server. If I have a kubectl installed, if I have a kube config file in the server, Jenkins server, will I able to execute kubectl commands directly in the Jenkins server, which will talk to that cluster? If I do that, yes, right? So I'm just creating one client machine. I'm just creating one client machine. This is normal machine. Now I'm creating this client machine. So what software needs to be installed in this machine? If I want to communicate, it is just a client machine. Do I need a Docker? Do I need a Kubernetes, or do I need any other software? This is just a client machine. What software is required in this machine? Just a client machine, this one. This can be your Jenkins server also, or any other server. Now in this machine, I will install kubectl. I will install kubectl. I'll install kubectl in that machine. It will take some time. Just wait till it is provisioning. This is just a client machine. Nothing is there in that one. It is still getting created. Let's wait for some time. Now I'll install kubectl in this machine. Whatever way you want to install, you install. Install kubectl. What is kubectl? You already know. What is kubectl, guys? It's a CLI, command line interface, client, Kubernetes client software. So I'll just follow these instructions and I'll install kubectl in this machine. Downloaded the kubectl binary, right? Then this is optional. Again, if you want to do that, you can do that. Then I will install the kubectl using these commands. That's it. Now I have a kubectl installed. You can just check. You can just check. I have a kubectl installed. I just have a kubectl installed. If I execute kubectl commands, will it work? If I see kubectl get nodes, I am getting this error. What is required for this kubectl to communicate with your API server, with your cluster? The config file. But how can I get the config file? Because it's a Kubernetes EKS cluster. How can I get the config file for a Kubernetes EKS cluster? But in case of self-managed, I can go to that server. I can go to that server, where, master machine. I can get the file in the master machine. etc kubernetes that admin file. But for this one, how can I get the kube config file? This is EKS cluster. Do you have access to the control plane? I mean to say, do you have any visibility or control to the control plane now? Now, how can I connect to this cluster, right? So I have a cluster, this EKS cluster. Now, how can I connect to this one? To connect to this one, how can I get the kube config file? So to get the kube config file for this cluster, what needs to be done? Using AWS CLI, you can get the kube config file. By executing AWS commands, you can get the kube config file. By executing the AWS commands, you can get the kube config file. So if I want to execute the AWS commands, do I need to install AWS CLI in this machine? First of all, I need to install AWS CLI. Do I have a AWS CLI installed in this machine? Is it working AWS commands? No. Let me install the AWS CLI. Let me install the AWS CLI. Whatever version 1 or version 2 of AWS CLI, let me install AWS CLI version 2 on the Linux. So what I am doing, these commands I'll execute one after the other. I am downloading AWS CLI zip file. I am extracting. Unzip is not there. Let me install unzip. Let me install unzip. Then install. Execute this command. Extract it. Extract this. Then, sorry, I need to press -y. That y, I missed that. Now extract it. Extract the zip file, that AWS CLI zip file, and install. Now I have a AWS CLI installed. AWS CLI installed. Now I can execute AWS commands. AWS EKS commands. AWS EKS, you can execute some commands. List cluster, like let me use -help or -h. -help. Okay, that is fine. It is not showing some issue. But now I can execute something like this: AWS EKS list clusters. I just install AWS CLI, which means this server has a permissions to access AWS resources. I just install AWS CLI, AWS concept. Now you can understand AWS concept. Now I can execute AWS commands like list cluster, AWS update config, that kube config file. You can get the kube config file, something like this. By execute this command, AWS EKS update config, your cluster name, your region, in which region you have a cluster. If I execute something like this, I'll get the kube config file. But do I have a permissions? I mean to say this server has a permissions, AWS permissions to manage AWS resources as of now. Then how can I give a permissions to this server? I want to give permissions. Either I can use role concept, either I can use role concept, IAM role concept, or either I can use which one? User concept. Either I can use role concept, either I can use user concept, right? So if I create a IAM user, if I attach EKS policies, if I attach EKS, maybe read-only policy, if I attach EKS read-only policy, he can just get the details, but will he able to delete the cluster or update the cluster if I just give read-only? No, right? So now, for now, what I am doing, for now, instead of creating a separate user or role, what I am doing, you know already AWS concept. I no need to explain that again and again. So instead of what I am doing, instead of creating all those things, I will be configuring my that server with this root user access key and secret key. This root user, I am using root user concept. You can use role concept also. Now I am using user concept, and again I am using root user access key and secret key. If I configure my AWS CLI, I mean to say AWS with the root user access key and secret key, since he is a root user, will he get access? Will he have all the access? Since I'm using root, I no need to attach any policies because I am using root user access key and secret key. I'm using root user access key and secret key. So I don't have access key and secret keys. I'm just deleting the previous ones and I'm creating a new access key. Now I am going to use this access key and secret key instead of creating a separate role or separate user. So I'm configuring this machine with user with that access key and with this secret key. Since it's a root user access key, we'll have access to all the services, all the permissions. I no need to attach any role also because I'm using root user. So this is the default region. Preferred output format you want to see in a table format or JSON format or text format, you can give. Now I have configured. Now if I execute these commands, since I'm using root user, can I see the Kubernetes clusters? List cluster I missed. There might be a typo. List clusters. Yes, is missing. Now can I see how many clusters are there in my account? Since I'm having a root user, he has all the access. If I execute EKS delete cluster, will he able to delete also? Because I'm using root. So in real time, you will not use root accounts, basically your own users. Okay. Now I can execute this one, kubectl EKS update config, this command, kubectl EKS update -kube config, something like this. Update -kube config -name, your cluster name. Name is this, my cluster name. Here name, your cluster name. And the region. Even though I don't mention, I configured the default region. Now I'm mentioning the region also. Now what this command does basically, this AWS EKS update kube config, what it does basically, it will get the kube config file for this cluster. It will contact this cluster and get the kube config file and it will be created in this machine. Now if you see, by executing this command, do you see it has created .cube and .config directory? And here, this kube config file will not use certificate based authentication. It will not use certificate based authentication. It will use user IAM based authentication. If you see, I have a Kubernetes cluster. This is the endpoint. Basically, the API server. API server is, this domain, this name is pointing to the Kubernetes API server. And if you see, it is using IAM based authentication. Now, since I configured this machine with root user, as a root user, will be able to access anything in the EKS? Again, will he have all the permissions in the Kubernetes also? Because I use the root user, admin user. So he can do whatever he want to do in the cluster. So in the background, whenever I execute kubectl commands, right, the Kubernetes will authenticate. It will get the token for this user, that root user, and it will pass the token to the API server for validation. Right? In the background, there will be a validation happens, authentication and authorization. Now I configured this machine with root user. Now I have a kubeconfig file also. Now can I see? Now my client machine is able to talk to the Kubernetes cluster. Can I see how many nodes I have in this cluster? How many nodes I have? 2 nodes. Do I have any pods, guys, as of now? Do I have any pods in the default namespace? You have a Kubernetes. These are the namespaces you got in the kube system namespace. In the kube system namespace, you have a kube proxy. There is one AWS agent also, AWS agent software, node software. There is some AWS agent software is also running as a daemon set. Kube proxy is running, DNS is running. But where is that API server, control manager, etcd scheduler? Do we have any access or visibility? Who is managing that complete control plane, that complete worker nodes, master nodes? AWS. It's highly available service. We just have a worker nodes in our account. Now can I create my pods, whatever pods I want to create in this cluster, or deployment stateful sets, whatever it is, whatever it is. Is there any difference in the Kubernetes concept whether you are using EKS or whether you are using normal self-managed Kubernetes cluster? Is there any difference in the concepts? No. But the infrastructure, you got the platform. EKS, when I use EKS, did I install any software? Did I created servers myself, either master servers or worker servers? So that complete platform is managed by the AWS. Now you just focus on your deployments, your application. You got a platform, you got a Kubernetes platform as a service. Now do I need to worry about the, if anything happens in my Kubernetes master or workers, who will take care? If something goes wrong with my worker machine, will I get another worker machine? In the background, it is auto scaling group. Since I have given minimum as 2, will I get another worker machine? Yes. But the Kubernetes concept remains same. Now let me deploy one application. Let me deploy one application. Since I have a EKS cluster, can I create a service of type load balancer also? Now, so let me deploy one application, maybe very simple application. Let me take. I don't want to type. You can use all those concepts, whatever we discussed, like pod affinity, node selector, volumes, volume claims, pods, deployment, services, everything remains same. There is no change in the concept. The Kubernetes concept remains same. So let me take some simple pod, one application. So maybe let's take this one. Let's take this one. Guys, if required, can I mention that resources, request limits, all these concept, requests and limits, liveness probe, readiness probe, if you want to perform the health on the application. Can you define liveness probe, readiness probe? And also, if you want these parts to be scheduled in a specific nodes, can I use that scheduling options like node selector, node affinity, right? You can use all those concepts based on your requirement. Now just let me mention CPU, memory, something like this. Now let's say I want half core CPU and 1 GB RAM minimum, limit 1 core CPU, 2 GB memory. Now let me deploy this one. And also to access this one, there is a one more service. There is a one more service in Kubernetes. What type of service basically? There is a one more service called load balancer. There is a one more service called load balancer. That load balancer is basically external load balancer. That load balancer is basically external load balancer. So I have a Kubernetes cluster, my Kubernetes cluster. The end user request goes to the load balancer, external load balancer. External load balancer will route the traffic to the servers, your Kubernetes servers on node IP and node port. Then request goes to the service, service to your pods. Now, can I use this service, Kubernetes service, that cluster IP, that service IP address from outside? Will it work? So end users, in the real time, does end users will use node IP and node ports directly? I mean to say, anywhere did you see like end users have using IPs and ports to access the application? No. So there will be a load balancer. This is external load balancer. This load balancer will route the traffic to your Kubernetes nodes, and again node IP and node port. End users will access via load balancer. In self-managed Kubernetes cluster, can I create a service of type load balancer out of the box solution? Will I get a load balancer created automatically in self-managed? No. You need to create a load balancer yourself. You need to define all the routing. But here, if I create a service of type load balancer, will I get a load balancer? This is managed Kubernetes cluster. Now, I am creating a service of type load balancer. Ports port 80, target port 8080. Selector, whatever you have given, app, Java, web app, this one. Now the moment I create a service of type load balancer, what I will be getting? In the AWS, do you have a load balancer ELB? Right, in AWS we discussed about ELB. What is ELB? Elastic load balancer, right? The moment I create that service, I'll get a load balancer. Basically, this one is separate. Okay, I am trying to demonstrate. I am trying to demonstrate AWS classes for other batch. I created a load balancer myself, all the target groups and all. Now, the moment I execute this one, I will be getting a load balancer here, right? I will be getting a load balancer here. Now, if you see kubectl get all. Now I got one external IP. What is this external IP, guys? That external IP is nothing but what now? I created a service of type load balancer. So now it has created a load balancer. It has created a load balancer. So external load balancer. Now, if this now here I can see that external load balancer. Now you see there is a load balancer created. Now if I map this load balancer with my domain, will I able to access that application using AWS DNS concepts, right? Using AWS DNS concept, if I map the domain, my domain with this load balancer, does end users will be able to access that application which is running as a Kubernetes pod, right? Now if you see, I got a load balancer. I got a load balancer. Who created this one? Did I manually created this load balancer, or the Kubernetes? That EKS has created a load balancer whenever I created this service of type load balancer. That EKS, Kubernetes, has created a load balancer. Now if you see, this load balancer is listening on port 80. It is listening on port 80 and it is forwarding the traffic to this port 3119. The request goes to load balancer, the default port 80. It is forwarding the traffic to 3119. So what is this port basically? On which node, on which servers, to which servers it will forward the traffic on this port basically? If you see, what is that port? Whatever I see in the load balancer, in the internally, what is that port? That is basically your node port, your node port, your node port, right? Request goes to the load balancer. Load balancer will route the traffic on this port. To which servers? Here in the load balancer, I can see some servers also. Two instances are there. There is a listener. Basically, it has created a classic load balancer, guys. It has created a classic load balancer, and classic load balancer has a listener. The load balancer is accepting the traffic on port 80. It is routing the traffic to this one, 31199. Basically, what is that? Your node port, your node port, your node port, that service node port. On which nodes it is forwarding the traffic? There are two instances. These two instances are what? Your Kubernetes workers. Now, if someone access via this load balancer, now the request goes to my Kubernetes pod. I mean to say, request goes to load balancer to the nodes using node IP and node port, then node that service to the pods. Now, I am going to use this one. If my pods are ready, is my pods are ready? First of all, yeah, my pods are running. Now, if I use that load balancer, where is that load balancer? I can use this one. This load balancer. Now, within this load balancer, I have this application context. This is my application context. Now once that is ready, now am I able to access my Kubernetes application? I mean to say that my application which is running as a Kubernetes pod container using this load balancer. Now if I do the mapping, if I do this load balancer, if I map with my domain in Route 53, will I able to access using the domain? That you already know, right? So now if anything goes wrong with this server, my Kubernetes worker, any of the server, will I get another node automatically, guys? If something goes wrong with this server, even though I intentionally stop this server, will I get another server automatically? That is because who is managing the nodes? The auto scaling group. Now, is it highly available, scalable, reliable Kubernetes cluster? So EKS is the recommended way to run your Kubernetes applications on the AWS. It will make you too easy to install, you no need to install, manage, AWS will manage. So next session, I will discuss about what is ingress, how it works, right? But there is a detailed video, guys, in our YouTube channel. There is a detailed video in our YouTube channel. You can refer that video before coming to the next class. Again, I am covering the topic, but it will be easy for you to understand what is ingress, Kubernetes ingress, right? There is a detailed video here, Kubernetes ingress controller and ingress rules. So I recommend you to go through this video before coming to the next class. So tomorrow, as I already told, I'll not take the class tomorrow. I have some function in my home. Okay. So the next class is on Friday, guys. Okay. So try to set up a EKS cluster and try to also go through this video. What is ingress, how it works, right? We'll continue on the Friday. Yes, AWS supports only Amazon Linux. That doesn't matter for you, right? You just need a node. You just need a node. That node will be using Amazon Linux. They have created one AMI, with very lightweight, right? Whatever works for a Kubernetes in a efficient way. Because you are not going to install any software in that worker nodes, right? You are just going to create a containers, your pods, right? So AWS has a supporting only Amazon Linux AMIs to create a worker nodes. Okay, guys, that's it for today. I'll continue in the next class. Thank you. Tomorrow, no class, I'm saying. So Friday is the next class. Thank you.